Let's look at the Poisson problem 5.22. The quality control manager of Merlin's Cookies is inspecting a batch of chocolate chip cookies that just been baked. If the production process is in control, the mean number of chocolate chip pods per cookie, so now one cookie is now the area of opportunity. Okay. And the average number of chocolate chip pods that you need to have is 6. So what is the probability that in a particular cookie being inspected, okay, fewer than 5 pods are found, or exactly 5 and 5 or more, and so on. So lambda is 6. Now x is chocolate chip pods per cookie. So let's define x equal to chocolate chip pods per cookie. Then lambda is 6 per cookie. And we want probabilities, and here is the formula. And A is fewer than 5. Fewer than 5. So you have to be very careful here. Fewer than 5 means 5 not included. In discrete probability distributions, okay, 0, 1, 2, 3, or 4. Okay, 0, 1, 2, 3, or 4. And the probabilities are, okay, now you have to follow that, right? exp to the power of minus lambda here, and let's make that absolute reference, times lambda, again make that absolute reference, to the power of x, okay, x is that, divide by x factorial. X factorial is fact x. Fact is the Excel function for factorial. Now that will give us the probability. Copy that all the way. Okay. Now we add all of that, so we find the sum. So probability of x less than 4, right, less than 5, or less or equal to 4, is the sum of all of that. Okay. Now we can find these probabilities using Poisson function also. Excel function, if you use Excel function, instead of the formula, so we can go Poisson distribution, Poisson.dist. So here is x, and then the mean, and make that absolute reference. Okay. Now, like in the binomial, you have to say whether you want cumulative probability or non-cumulative probability. If you put 0, that means individual probability. So let's do individual probability first. And you see you get exactly the same numbers. And of course, now if you add all of them up, you get probability of x less than 5. If you used cumulative, okay, we'll do one more Excel function. So if you do Poisson dist, now if you use that x, okay, and lambda, and now if you do 1 instead of 0, that is cumulative. So it will go start from 0 all the way up to 4, and that's exactly same as what we got there. Okay, so that's A. Now B, exactly 5 is found. So we want exactly 5. So x is equal to 5. Okay. Now, if you copy any one of these formulas, that will give us the exact probability. So e to the power of minus lambda, lambda to the power of x divided by factorial x. Of course, we can use Poisson function also. So we can use Poisson dot dist. So x is 5, lambda is 6, and remember we want individual probability here because we want exactly x equal to 5. So you have to select 0 there. Now C is 5 or more chocolate chip parts. 5 or more. Okay. So this is going to be impossible to compute because 5 or more, there is no upper limit in Poisson distribution. So you have to keep on going even though it becomes small, very close to 0. So instead of trying to compute 5 or more, what we can do is look at 4 or less. Okay, 4 or less, 0 to 4 is the opposite of 5 or more. So we find 0 to 4 and then take 1 minus sum of that 0 to 4. That will give you the probability of 5 or more. Here probability of 5 or more is 1 minus probability of x less than or equal to 4, which we already have that here. Okay, that's that. Less than or equal to 4. But let's do it this way. So 1 minus Poisson distribution of 4, that's for x, and lambda and cumulative. I'm sorry, 1 for cumulative. Then that will give us the probability of x greater than or equal to 5. Now D is either 4 or 5 chocolate chips parts will be found. So 4 or 5, so which means you have 4 or 5. You have 4 or 5. Okay. And then we have to find the probability, and we can copy the probabilities from here, the formulas from there. Okay. And then probability of x equal to 4 or 5 then is the sum of these two. Okay. If you want the expected value variance, well, expected value is lambda itself. Variance is also lambda. And the standard deviation is, of course, square root of the variance. So this is Poisson distribution. You should be able to use both the formula as well as the Excel function to be able to compute these probabilities.